Video screencast number 1. Position over time versus velocity over time. Take 2. On the left side we have the position over time. And there's the graph. It's got a 1-to-1 ratio on the slope, which equates to a constant velocity. On graph 2, position over time is on the left. The position isn't increasing or decreasing over time, which gives us a velocity that also is increasing over time. It just stays put at a 0. Graph 3, position over time is on the left. We have a slope of a -1/1, which is a constant slope, which equates to a constant velocity. Graph 4, position over time on the left. Got a slow start with a sharp increase. With the velocity over time graph, got a minimum velocity at first. The little horizontal position there is the constant velocity, which was the 1/1 ratio on the slope. And you have a large velocity and then even a larger velocity in the end. Graph 5, position over time on the left, with the differential being a constant velocity at first, a minimum velocity, and then a large velocity. We got the constant velocity here in this little short distance, got a minimum velocity, and then even a large velocity down here. Graph 6, got a parabola facing down on the position, which the velocity over time graph. You got a large velocity at first with the minimum velocity here. This horizontal position is a constant velocity, and then we got a minimum velocity and then a large velocity. Graph 7, I don't even know what to call that one. But we got a position over time on the left and the velocity over time. This area here, position over time, computes to a constant velocity. And we have a 0 velocity in the horizontal position here. This is the 0 velocity. And you have a real large velocity at the end. This is what the real large velocity is. Graph 8. It's a 1/x graph, y equals 1/x. We have the position over time over here, velocity over time on the right. We've got a real large velocity to begin with, and then a big velocity, a little constant velocity, and then a 0 velocity where it crosses the t at. Last but not least, position over time mimics a sine wave, and the derivative of a sine wave is a cosine wave, which is a large velocity, constant velocity, back to a large velocity, short little constant, large, constant, and then a large velocity. Hope that was informative.